everybody. My name is Etienne. I'm very happy to be here. Our talk today is called Kotlin Likes to Demoparty. So just a show of hands, who here knows what the demo scene is? All right, good, good. It's also good that not all of you know what it is because, you'll learn something. All right, so today's an exploration of the demo scene. It's a computer art subculture, and we're going to explore that subculture using Kotlin. So, well, before I dive into the early history, I just want to say a big thanks to the Kotlin conference organizers, JetBrains, everybody. Really awesome to be here, and thank you for your support in bringing a speaker here all the way from Canada. The demo scene is something near and dear to my heart because since I was a kid, I've been fairly involved in it. I used to organize demo parties back in Montreal in North America in the 90s, which was a very rare thing in North America back then. So I'm happy to get a chance to share all this with you. So what is it? Well, I touched on it earlier. It's a computer art subculture that's focused on producing demos. Now, demos are self-contained computer programs that show off programming, visual arts, and musical skills. The demo scene's roots can be traced back to something called a cracktro, which this is an example of. These were short demos that were created by software crackers who removed copy protection from computer games in the 80s. Now, these screens served to demonstrate the crackers' skills, right, and often featured impressive graphics, really fun music, and scrolling text, crediting the group responsible for the crack. Now, pirate groups would often also diss each other and say hi to each other, and I've seen more than one cracktor with like whole rants and all sorts of stories and dramas that teenagers were having back then. Sometimes serious, sometimes not. Now, of course, back in the 80s, you have to understand that modem speeds were pretty miserable, and the internet was not very widely available. So what happened is that kids in the Northern Hemisphere sometimes, literally had to walk a few kilometers in the snow, carrying their computers, all the way to a meetup or a get-together just to get access to reasonably priced pirated software. Now, these were also great opportunities to learn a fancy programming trick or two from your friends, your peers, your nemesis. So given that you had a whole bunch of computer nerds basically meeting infrequently in MeetSpace, and there was a total absence of social media, as you probably know, it also explains why they would be so passionate about those scrollers and would send messages to each other, right? Messages in a bottle, effectively, getting sent over floppy disks and copied over and over again. Now, yeah, the perfect recipe for fun, if you ask me, right? This is a pretty big example of one of such copy parties back in the day. And for me, at that age, I think I would have been like, man, this sounds like the coolest thing ever, right up until you get busted, right? So this is what happened. This little party got busted by the police. Now, you might wonder, what did they do with those hardened criminals, right? They actually decided to forgive them. From the entry that I've linked below here, what happened is that the cops showed up. Everybody was obviously something like 13 or 14 from this picture. And there were about 150 people, or 150 kids there. And the police just told them, copying software is illegal, it seems. So don't do it, and we'll just, let you have your party. So that was covered in Norway's newspaper as well. Not this one, this is more of a trade publication for the day, I guess you could call it. Out of this demo party was the winning demo, because obviously they didn't copy anything at this point. So this is a solid 6-minute entry, which to my Philistine ears sounds like it had pretty cool music for the Commodore 64. I think those effects are pretty hard to achieve, on back then anyway, the techniques that they knew. So obviously I'm not going to play the whole thing here. But if you're curious, there's a link to the YouTube and to the actual C64 software on the Internet Archive. So at the end of the day, the demo party concept had a lot more legs to it than just like the shadier copy party. right? The demo sceners started getting their hands on more powerful hardware like the Atari ST and the beloved Amiga. Demos and intros started to get more and more impressive. So here you have like invitations to such parties, like one that was pretty popular, apparently, that Holland is okay, which is more than okay in my opinion, but hey. The other invite is for what has now become known as one of the bigger parties, which was in Denmark. So it was like the first such party. There's also a video of that event right there. So you kind of get the feeling like what it was like to attend these things back then. So by the mid-90s, the European demo scene had become huge. Some demo parties reported thousands of people, thousands of attendees. The competitions became big deals, like they had cash prizes, sometimes in the 5 figures, hardware prizes, big sponsor deals, live shows. They became really big productions. Now, so we're going to take a break from the history lesson, and we're going to start thinking about how we could actually build our own little demos and participate in this movement using Kotlin. So, back in the early days of demo coding, everything was pretty much done in assembly. So now we have the real big luxury of having a fully featured language, having really powerful IDEs, and there's a great ecosystem of different libraries that we can use. So I ended up looking at 3 specific libraries, or frameworks, I should call them, all pretty good. So the one that I was looking at first was LilKT. I wanted something lightweight. Pretty interesting, I liked it, tried it out. Corgi is, I think, or Corgi, I don't know how you pronounce it, but I think that's a fairly popular one. I've looked at that too. I ended up picking something a bit different called OpenRender. Now, I liked the fact that it was targeted at live installations. It had more of an eye on, MIDI controllers, OSC controls, Arduino, integrating with Arduino, TensorFlow, some machine learning stuff, connecting with Kinects, cameras, all of that. So I kind of liked the idea that if it's more of a tool for creative expression, that I would get to eventually tap into all of these things. Not stuff we're going to look at today, but I liked the idea that it had legs, this library. So, it caters more to live art installations than gaming. I should mention that it's an open source project that was officially launched in June 2018. I believe it first started as like a processing library on top of processing in Java, and they ported everything to Kotlin back then. So a quick shout out to the maintainer and lead developer of the framework. He's named Edwin Jacobs. I've had a brief chat with him on Slack. Nice guy. He helped me out with a few things. He's in the US today for some other conference, but anyway. So let's get live coding. Hopefully things will not go terribly wrong at this stage. So I will just adjust my screen so that we can actually all see the same thing. And here's the moment I cross my fingers and hope that not everything explodes. All right, so we're sort of in good shape. A bit small if you ask me though. Let me just adjust for the audience. I'm sorry for those little delays. I was expecting that. It's always the monitor setup that kills you at the end of the day. So we're just going to make it a bit more readable. I'm going to double check with you, the audience. Can you read this text? Yes. Yes. All right, that's good. We're in good shape. Okay, so we're going to start this. So another reason why I quite like OpenRender is that it is quite conducive to doing this kind of live coding exercises. So I actually have here on the side my reference work. I'm just going to double check a little bit my notes. So structure of things is that you have a main function and you assign it to this application right there. First, you need to sort of configure things a little bit. We want something that's relatively low width and height. So very low resolution. It's sort of on purpose. Like today, we're going to be doing more retro-looking feel things. I'm not like somebody that goes as SciGraph regularly and has like very deep knowledge of graphics programming. Hopefully, this will relate to you all a little bit, and you'll learn something from me still. All right, so we're just going to start with like the basics and have like very, we're just going to clear that screen and start the program and test that things work and also make sure that you can see the results. So is that working? Not really. What's going on? Well, actually, I made a mistake here. So the way that this thing works, OpenRender works, is that you have a program and then your render loop is actually in this extend block right here. So now that we have this, I can save, oops, save, recompile, restart, and there we have it, the pink screen. Now it's going to get old really quick if I have to rerun every time, even though the compilation is fairly quick here. So OpenRender has this really nice little feature where you wrap this in an OLive program, and now when we restart it, hopefully for the last time, when we change our parameters, we're going to have the luxury of simply being able to, right there, hit save, and typically this should update. There we go. And then the screen has turned that nice shade of gray. All right, so first thing we're going to do, I'm going to start copying and pasting code here because I know we're going to run out of time otherwise. So a big block of code right there. I'm doing some circles. Now, don't worry, I'll actually explain what's going on a little bit still, right? So we have this idea that we'll first start with a color palette. So I've here made a small list of different colors. Then I'm going to define some circles. So this little loop right there, I've defined circles. I've gone fancy, right? I've went with steps. I'm defining points on the screen. So I'm using this vector2 class, fairly simple, right? X and Y coordinates. And as you can see, I'm sort of stepping through the screen on the horizontal. Then what I'm doing here is I'm setting the drawer to have a stroke weight of 4. Now you might be thinking, wait a minute, does that mean that this thing is stateful as hell? Yes, it is. Like a lot of graphic engine libraries, what have you, whenever you're sort of playing around with these things, you're in a very stateful environment. I'm told it's for speed. All right, so the next step here will be to actually draw those circles on screen. So if I save here, with any luck, there we have it. Recognize those colors, right? Nice. Okay, so that's kind of fun. Now, obviously, the advantage to these techniques is that if we're redrawing live, let's say we want to put this at the 3/4 height of the screen, I hit save, and with any luck, there we go. We have those circles at the bottom of the screen. Cool. All right, so what else are we going to play around here with? Well, you're going to laugh again because I have another huge block of code I'm just going to brazenly paste in there. But you'll see why in a second, because this would have taken forever to type. So what am I doing here? Like, what's this thing? Is it going to show up? Recognize that logo? Fun. All right. So we just created a list of points. What I'm using here is like a concept in OpenRender called contour. So we're fairly high-level primitives here. Like we're defining a line which is like running around, and we're creating shapes. And so by moving our pointer, this first section here is like the triangle that's at the head of that bird I'm seeing in the logo. And you have another section of points that we're defining here, which is drawing the rest of the logo right there. So that's not exactly what we want, right? It's not in the right corner of the screen to start with. So we could do something called a translate operation. Now, at this point, I'm going to mention something. You might have noticed that, I mentioned how everything was stateful a bit earlier. I have here this idea of a drawer isolated call. So when we call this in OpenRender, it actually pushes the state onto the stack. You can change things around, and when you're done and get out of that block, it's going to pop out the state, and we're going to not affect the rest of our render loop, right? It's going to be localized to that little section. So, looking at time, because I can tell you something, I was really worried about time when I was preparing this talk. Okay, so we just changed the color. Another thing we did was we set the stroke to null, so we took it out. So that way it looks a little bit more like the actual Kotlin Conf logo. Okay, so I can tell you right now we're not going to get to the point of having a scroller and having like that nice chiptune music going on for this specific part of our little demo. We have other stuff to do today. But I will at least put a little greeting of sorts, right? And I'm sorry, I didn't take down all your names when you came in, so I can't have like a 12-minute long scroller that just says hi to everybody. That's not going to happen today. Maybe eventually we'll just hook this all up to Firebase and you can actually subscribe and enter your own names. I don't know, something like that could be fun. But meanwhile, we're going to keep things a bit short. I'm just going to tidy up things here to be able to see what I'm doing. So I'm going to introduce the concept of using fonts. So you see I'm missing a certain thing here. I'm going to talk to that So the other thing that we have with Open Render programs, which is, I think, pretty interesting. Okay, so first off, right, I mentioned, I think, I might not have mentioned that the extend block is effectively our render loop. So if you have a render loop, you don't want to be loading images and resources and whatnot in that render loop. That would be bad and wasteful. So what we're doing is that outside that render loop, we can load our different resources and have access to that. What is interesting is that you're still in that live program. So whenever you're changing things around, you'll see the changes happen live on screen. Before I hit save, I'm just going to like go over a tiny bit what's going on here. Like a small explanation is kind of interesting. We're still using that isolated call to save the rest of the program from being affected. We assign, though the thing to note is that in this section, we're in the context of a drawer. So everything we're calling that font map, that's an attribute of the drawer that we're changing. The fill, same thing. We've seen a fill earlier. And we have this other thing here called a writer. A writer allows you to do pretty fancy text manipulation, something that I find in a lot of game rendering libraries. Whenever you're playing around with TrueType fonts, things get really gnarly really quickly. And Open Render is kind of nice for that. It allows you to really load up a string and manage to even measure and size it depending on the font that you decided to pick. So what we're doing here with this block right there with the text rectangle, we're creating a rectangle and we're sort of assigning it to the center of our screen. So these are really tidy, shorthand operations. We don't have a lot of code in there that's like, doing dividing and basic math. So I kind of like how quick and fast it is to work with. We can calculate the width of our string beforehand, the height of the font, and then decide to precisely lay out that block of text at the end of this whole little loop. So what happens when we hit save here, we have a nice little hello Kotlin font, right? Bitmap font, everything. I'm happy with that. Actually, no, I'm not exactly happy with that. I'm gonna, you see this commented line here. We're just gonna put it, a little bit in the right place in there. All right, so that sort of shows off a tiny bit what Open Render is able to do for us. But that's fairly basic stuff, right? We're not really at the level where we're doing bitmap graphic and fancy stuff yet, but that's the starter block. All right, so I'm going to go back to my slides now. And how are we doing on this? Oh, wait. Forgive me, I will now stop mirroring and start this again. Hopefully I'm not going to mess up while I'm doing this. Okay, there we go. So that was our little live coding block. And we're doing okay on time, I think. We'll see. All right, so getting back to the history lesson. We're in the 90s, early 90s. Something interesting happens. Now, who here knows what a modem is? All right, cool. So for those of you that know what a modem is, I'm not telling you anything new, but back in the day, you had this idea of like the modem with like an acoustic coupler and with those old funky phones that you'd hook up the receiver to, and then, noises would happen and you'd get like a big 300 baud, that's 300 bytes per second connection, right? So that explains why copy parties were a thing, because like the Pigeon protocol, if you know the Pigeon protocol, it's this idea that you can do HTTP over Pigeon. If you have an SD card, the throughput can actually be pretty incredible. Same thing here, like except teenagers walking in the snow. So anyway, modems get better in the 90s, which is the point of the slide. Like the 300 baud in the middle there you see with the RS-232, that was like the big step up from the original ones because you didn't have those acoustic couplers and all of that. But I used to own one of those big things, those funky white little box things, the US Robotics Sportster 14,000, right? That thing went fast. And it sort of ushered in an era of the era of the BBS. Now, BBSs back then were crucial to the growth of all sorts of things, but specifically the demo scene. And with faster modems, the whole ecosystem started really thriving. So if you're ever curious about the BBS scene, which I'm not going to dig in too much into that, because that's a rabbit hole, I encourage you to check out this BBS documentary by our digital archivist friend and historian of technology, Jason Scott. Both pictures here. I've actually met Jason Scott back when he was in that cow costume, before he was a star, or before his cat was a star. If you know him, he's got like the cat with the most Twitter followers, or at least he used to. I'm pretty sure Jason's no longer on Twitter, or at least he's probably not a fan of what's going on. Part of the BBS ecosystem explosion, we also see the birth of quite a few weird and quirky demo scene adjacent art forms. Since BBSs were all text-based, well, ANSI art makes its apparition back then. Text-based BBSs, right, before you had ANSI art, they were kind of bland, right? Like you just come in and it's just text there. So folks that could do these kind of graphics became in demand pretty quickly. If you were a good, fun, especially demo scene type website, you had one of those big splash screens going whenever somebody logged in. So this group of young people were the ACID ANSI group. So ACID stands for ANSI Creators in Demand, if you're wondering. That's one subculture that was born out of the demo scene. Another weird sort of extension was the disc mag. So the disc mag, this one is like a very popular one that's called Hugie. I hope I pronounced that right. Started in the mid-90s. Content was mostly based on contributions from the readers. People would edit it for sure, but they just packaged this on one disc, that's the disc mag, and you had animation, music, text. Effectively, you know, sounds like a website, except you didn't have websites much back then. HTML wasn't really a thing. So that sort of replaced it, except, you know, you had demo sceners contributing, so you can imagine all sorts of animations and funky things going on there. So quite an interesting sort of thing to check out if you've never heard of it. So at this stage, right, we got this whole ecosystem thriving. Coders, demo scene coders, sometimes at the first were alone, but they, you know, productions are getting bigger, people are interested in more fancy stuff, so you start getting a specialization of roles back then. You have graphic artists using software like the one featured on top here called Graphics 2, which was based on popular pixel editors from the time. At the bottom, you have something that, if you were in the demo scene, was pretty classic, trackers. So those allowed you to have short samples and start making music as if you were using a fully fledged professional sampler, except you would use these pieces of software and sort of try to push the boundaries of what you could actually fit on a disc and sort of try to get like a fancy song going. So all of this is going on, and people are staying in touch over the BBSs that keep popping up. So that's how I originally was exposed to the demo scene, made friends I'm still friends with today. So quite interesting things. All right, so now let's try to go back, you know, to our coding. We're leveling up. Let's put ourselves in the shoes of an early 90s demo group. We're going to start a demo. So how did that whole process go? I'm just going to go fly over that very quickly. First off, you start thinking with your team, okay, so what do we want to do? So you make a mood board, right? What would be nice? Scrollers are kind of, you know, boring at this stage. So you just start brainstorming a little bit. In this case, I actually did this exercise with my wife, who's like, who's drawing my pixels. I have a good friend that actually still makes that kind of music. We brainstorm. We all agree that a retro aesthetic would be nice. You know, we're not 3D engineers by trade, but we like to do our little pixel art and retro stuff, so we're going to go with that. And we pick our home city of Montreal as an inspiration. So we have brutalist things going on, graffiti, weird mascots, like city features, all of that. So we're sort of brainstorming all this stuff. We end up picking a couple of things that we're going to see in a sec. So those two visuals are from like sort of Montreal landmarks pretty much. If ever you visit our city, you'll probably be told, oh yeah, I should check this out, it's kind of interesting. Anyway, so to create our composition at this point, we want to do a bit more pixel manipulation. So we're going to start using fragment shaders. Strictly speaking, not the kind of tools that you would have available in the 90s by far, but it's actually not so distanced from the idea of manipulating pixel data with low-level code. So I'm assuming some people are aware of shaders here. Quick raise of hands, like shaders, messed around with them a little bit. Okay, so it's good. I'm going to do basics. So since the crowd is not super familiar with it, you should benefit from it a little bit. The idea of a shader, if you don't know what it is, it's a software program. It's effectively a function, so we're getting back into the functional realm pretty much here. It's a function that will run for every pixel that is shown on screen, and the function basically takes all sorts of parameters and will spit out a color. So you have to sort of think about graphics in a bit of a different way when you're starting to work like that. So I'm going to show you how that works a little bit, and I'm going to stop the presentation again, quickly switch our screen to try to not consume that precious time that we have left. It's always a bit of a challenge doing live coding and having to toggle between all these things. All right, please mirror my built-in display. There we go. And I have to reset the font size again. All right, cool. Okay, there we go. So I'm going to stop the original program. We're going to go to our second filter program. Sorry, I have these little placeholders ready to go. Okay, still readable. If somebody stops me if you can't see a thing, that would be sad. Right. Okay, so shaders. What are they? Well, I told you that already. All right, so we have a few steps here. One of the things I'm going to quickly do, I said quickly, there we go. All right, I'm going to just add, I'm not even going to explain this, but I have like a frame per second counter that I want to have displayed in everything I do, so that's like part of prepared code I have. Of course, I'm going to be sharing all this code, as you probably would expect, but that'll be for later. All right, so first thing we're going to do, we're going to start loading our graphics. Like specifically this time, I have one of my images that's split in 3 pieces. So I mentioned how we load graphics outside of our render loop, right, to keep things tidy, so that's it. Those are the 3 layers. That milk bottle I shown earlier that we're going to be rendering in our little proof of concept. Then I'm going to show this on screen. So we're going to start with a drawer. Well, you know what? I'm actually going to copy paste again because that is definitely taking as much time as I suspected as it would, which is way too much. All right. Right. Oh yeah, actually, I did that terribly. Okay. To save everybody time, I'm actually gonna just copy whole block wholeheartedly and start explaining it, which is not what was my original plan, but hey, you know what? That's how things work. All right. Okay. So we're going to focus really on the image loading. My plan has been destroyed right now. You see this, right? Who here is surprised? Okay, so I'm actually going to go through the code and start running it and explaining it very quickly. The first thing I want to explain shortly is this concept of the shader right here. So I have a few shaders going on. I'm only going to show you the first one here, but my first shader is going to apply a sky backdrop to our little demo. So what I'm going to do here is I'm going to hide all the other ones so that you don't get spoiled too quickly on the surprise, at the very least. And we're going to run this. So at this stage, we're going to see effectively what we were supposed to see at the beginning of this. No, not you. Sorry about that. All right. Filters KT, there we go. Live demos. Everybody loves those, right? What a great idea. All right. All right, we have music going too. Oh, wait. No, that's not what we want. All right, so warning to the wise, which is not me in this room. The problem with this awesome system of the live program is that if you have the bright idea of putting music in there, guess how many times it spawns up the loop for the music? It's going outside of a render loop because we're not talking about graphics, so it just screws it up really quickly. Okay, so this is our backdrop. This is our setting for our shaders. So we have this little graphic going, and it's spliced into 3 different windows so that we can apply our shaders in layers, right? And so the first shader that we have is our backdrop to the sky. So I'm going to turn it on, and I'm going to go into the shader code itself, sort of demo a little bit how things work right here. So we have a shader. So who here is familiar with Shader Toy? All right, not too many people, so I'm going to teach you something today. It's like maybe the one big takeaway of this talk. There's a wonderful website, which I will link to in a second, called ShaderToy. On ShaderToy, you have a multitude of shaders that do all sorts of different things. There's 3D, there's rendering, there's this little effect right here, which is the most basic of shaders. But the key is, if you want to learn how these things work, the learning material is all there. So we're going to jump into the actual code of one of these things and see how we can tweak it and how it works a little bit and get more of a feeling for it. Because I think we're going to fly through all of the rest of the shaders at this point, but bear with me. I will at least teach you the basics today. So for our talk, we have the simple sky. There we go. So the simple sky at this point is just showing you the default shader toy changing colors in your screen. So what does actually the default shader look like? Because it is interesting. So the functions that you should look at are the main image right here. That's the function. The setup I have in this project allows us to import any shader from ShaderToy into OpenRender and start messing around with it. And it has effectively a template around it so that it makes it very, very simple to import those and learn from those. One of the very neat things about this setup is that you can change this live, just as if you were doing live code in other frameworks. Or in ShaderToy specifically, you can do live framework. So to give you an example, let's say I want this thing to stop color cycling all the time. So I can find a bit of code in this shader that actually assigns the color and multiplies it, adds time to it. So this right here is why we're seeing a cycle in colors. Every pixel is being called. It's looking at the wall clock on the wall and says, okay, I should be this color at this time. So if we take out this time aspect, we're going to freeze everything there. And there we go. So the shader stopped moving. It is frozen in time, and things are like that. How does the shader work? I mentioned it's a function. Well, we're looking at it right here. We have an input, which is the fragment coordinates, effectively where you are on the screen, like what's your address as a pixel, which X and Y do you have. We play around with these coordinates. We normalize them from 0 to 1. So now we're more in the mathematics space, right? So if we normalize things between 0 and 1, we can start applying math functions to this. Instead of being at pixel 600, if we're at the edge of the screen, we're at pixel 1 and maybe -1 on the other axis. So then we can really start thinking about things mathematically. Now, if we want to, we can decide that we want to set everything the same color. And since this is RGB, so if I want it to be green, I'm going to create this vector 3 here. I'm going to assign 1 to the green portion of it. And if you're seeing here what we're doing, we're creating a vector 4, and we're doing this weird operation. What exactly are we doing? Actually, the vec 3 is kind of silly right there at this point. But what we're doing is we are creating a color. So RGB and alpha. The alpha is the last component. So once I save this, we should have like green. There we go. Okay, that's good. So we want to get something a bit more interesting. So we want a sky. The sky is going to be a gradient. So I took, as you will probably do the same if you play around with this, I took something pre-baked from ShaderToy and adapted it a little bit by playing around with it. So I'm going to take that and copy it over. And we should start seeing a blue sky here. And I'm just going to save. And we have a nice little gradient. That's, blue sky. That qualifies. Like, we don't need to dig into the exact numbers, but effectively what this is doing is creating a gradient from like orange tints that you would get at sunset right up to the blue of the sky at the top of the sky. And from that, we take a slice. We just decide, depending on our y-axis, where we stick it. And there we have it, blue sky. So that's pretty simple. What else could we do to make things a bit more interesting? So if we jump back to our filter code, we can add extra shaders and layer them. So in this case here, the sky is behind everything. You can actually see that the windows are transparent in the pixel art and that we see the color of the shader behind everything. Next step up, we enable this second shader. And here we have, wow, actual text scrolling around the screen in the sky. What the heck, right? And we're still, you can see, in the layer behind everything else. So we're going to take a quick look at the shader just to get a feel for what these things look like and sort of Again, I effectively took code from ShaderTool that was doing something completely different, was mapping pixels on the horizontal plane, and just repurposed it for this silly little example. So that's what happens when I'm on a stage. I forget all my shortcuts and everything, but there we go. No, not the janky one, the nice one. All right, cool. So what does this kind of code look like? It looks like this. We have small divisions, multiplications, but effectively what we're doing is like we're projecting two planes. We have a texture that's fed in. So the way that you feed a texture is through something called a sampler in OpenGL/SL, but what this is a 2D array of pixels. And once we're down in the shader code, we can access this through a function called texture and pick and choose the pixels in this. So what I've done in the main app is I took a TrueType font, I created a big ribbon of text, I fed it into the shader then has access to this, and over time it decides to pick something out of that array, effectively. So if I stop the time, then the text is frozen in the sky. If I let it run, that's fine. If I play around with some axes, I can sort of stretch it in that way, where if I, completely flip it, all of a sudden we're going to have the text upside down. So they're very simple manipulation. Of course, this kind of looks like gobbledygook when you first look at it, right? If you're not used to shader code, you're like, what's going on here? What's interesting with shaders is that they're very short. So if you take a good sample, play around with it, play with the numbers, you start to get a very gut feel for, oh, this is what's going on. And before long, all that gobbledygook becomes like something absolutely understandable. All right, so I'm going to jump quickly back to our filter. So I'm just going to enable the rest of the pieces of this little puzzle. And that's going to finish our first part. So we have a star going on here. We just layered it differently. Stars, you might be wondering, how do you do shapes if you're calling a function and the function is just giving you a color? So how do you figure out, do you have like a very long program that like decides what shape of a star is and decides if the pixel is on and off? Like, that must be horrible. It's actually pretty tidy. So the idea with this is that you can use mathematical functions that describe your shape and just decide if a point is in or outside that shape. And that's the basics of it. So if we take our fragment star code right here, and that's actually a very big takeaway if you want to mess around with shaders, and I'll explain why it has more applications than just doing geometric shapes on screen in a few seconds. But if we look at the shader code right there, we can see that we're doing some slight manipulation on these axes to turn our 650 numbering system into, again, the 0 to 1 mathematical normalized coordinates. And so once we have those, what we do is we call a function that decides how far are we from a star. So that function right here is called SD star 5, and it describes mathematically what a star is. So it is fairly complex, but you can describe other shapes very simply. A circle, for example, is just how far am I from the middle? Am I inside the radius? So if you, for example, if you were to turn you were to look at more of a circle shape with this, all that this function is doing is that for each point it says, how far are you from the circle? Oh, you're inside of it, you're yellow. And if you're not, you're not. Things that you can do when you start messing around with these things. If you want to have both a star and a circle, what can you do? Well, you can create a star and a circle and measure, the distance that the one given point is from both things. And then you do a union method, which is effectively saying which one is the smaller. So which thing am I the closest to? Am I inside or outside of it? And if so, I will be yellow. That's the idea. So in this case, you can see that I have both shapes on screen. And that same function basically looks at both shapes. So you can start doing very fancy manipulations that way. You can even do things like multiply your domain. You can apply a modulo on the parameter, and all of a sudden you have an infinity of stars on your screen. So those are tricks that you can pull when you're starting to use math to effectively describe your geometry. I'm just going to go back to the original star here. And if you want to animate things, you probably already got the gist of it, but you're able to, actually not this guy here, this one here. So if you want, you can rotate your star and actually even shrink it or grow it depending on the time, and you have an animation on screen going on. And at this stage, well, that's where you might want to turn off your live updating program, put on the music, and have like a little sort of intro going on, which I will do promptly, just to at least we can all see the end results of this thing. So by doing this, re-enabling the music, this time it shouldn't become a train wreck. And oh yeah, of course, I turned off the live updating, so it's not going to do much, is it? All right, there we go. So I'm not going to be showing you today how to animate to the beat, but you can already get the impression of it. You feed a value into the shader saying, hey, a beat is on, or you could decide based on the time that you follow rhythm and animate the things as you need to. All right, well, that was fun. Let's turn that off. Okay, so I'm going to go back to our, yeah, that's not going to work. I'm going to go back to our small history lesson. I'm almost out of time, so I'm going to try to breeze through it and give you a bit more information so you can look up, you know, on your own how you can have fun with all these concepts. All right. So here is the page that will talk about signed distance functions in 2D and really go through them. Effectively, what people do when they start messing around with shader code, they have a shader library with all those functions and start messing around with the geometry. What's fun is that you can describe very complex scenes with fairly little amounts of code. So that's why a lot of really impressive things on ShaderToy are very, very short. At some point they had this contest called the 2-tweet contest. That was years ago, but the idea was, what can you do if you have 2 tweets worth of shader? And I'm not talking about like the big tweets, I'm talking about those old school, however many characters we used to be able to have, right? SMS length. If you're interested in shaders, a good place to start is the book of shaders. That's a reference that keeps coming up, so I definitely recommend this one. It goes from the beginning to the end of, you know, the concepts that you need to learn. If you're curious about that weird music I was playing, it was from a demoscener friend of mine, and do we have an animation on this? It was built on an actual Fairlight. If you know what that is, those are fairly old synthesizer and trackers. There's a lot of history there too. It's very interesting. But part of the reason it had such a weird little sound is that it was built on this ancient device. Other stuff. We're not going to be live coding more music today. I'm just going to talk about the modern day scene. And since I'm almost done, we're going to breeze through it quickly. I'm going to give you all the links that you need to sort of learn more about the demo scene. Anyway, demo scenes have gone really big, as you could expect these days. Graphics cards are available. Graphics cards are super powerful. You need them because each core that's on there, each GPU is actually running those little programs I've shown. So if you start doing fancy stuff, you need more and more cores. NVIDIA, unsurprisingly, has gotten into the demo scene game very, very early, not in 2015. They were there since the very beginning. They've been sponsoring demo parties and whatnot. And they ran a few events not that long ago. Well, that's almost 8 years now. So yeah, it's 8, 9 years. It's been a while. But if you look up those events online, YouTube specifically, all those talks from that era have been put up there. And I think most of the information there is still very current and very pertinent today. So you might want to look at that. Something I had apparently no hope of getting to, but I foolishly believed I could explain today, was how to use the same concepts I've shown you for the geometric shapes and do 3D rendering and ray marching. The scene that you see up there is rendered using shader code only, and this stuff can actually move. How did they manage to pack that much graphic information into a shader? Same concepts I've just shown you. You described with your signed distance field functions, you describe your geometry, and you need to take a different approach though. You can't just say this pixel is inside or outside the object, right? It's in 3D. So one of the big concepts there is the distance-aided ray marching that makes this effectively possible to be used on a shader. The idea is that you throw a ray into space and you basically do the same kind of calculation. How far am I away from the point? And you try to reach small increments until you're close enough to the surface to say, there's a point there, I'm going to color it color X. All right, no live coding whatsoever. I'm just going to show I know I'm out of time, but I'll show very quickly the links to the things so that people can really benefit from it. Also, I'm not slowing down anybody since I'm the last talk of the day. So forgive me. Shader toys, very good place to go. These are the 3D primitives that you might want to check out. Everything is there if you want to learn how to do ray marching. I was going to mention some other stuff about the scene, but there's like very active groups. That group, Razor 1911, is the actual group that organized that kids party in the 80s. They're still around. They're still making demos. They're releasing their music on vinyl. Yeah, it's really cool. Another thing that keeps coming back about the demo scene is like everybody will always tell you every decade it's dead because it changes every decade and nobody likes change. So, ANSI groups, they're still around. This is from 2013. They were featured on The Verge. It made the news. It's like, ANSI in 2013? Really? Okay, cool. What else? People do retro demo coding a lot. It became super popular. So you still have modern productions on Atari ST, Commodore 64s, MS-DOS, what have you. And honestly, the techniques they're showing off nowadays are insane. I would not have thought this was ever possible back in the 80s. Other stuff that people do, this one is insane. I have to show it. This demo is using old hardware. It's not actually running on a PC. It's running on the floppy drive. This person just hacked the firmware of the floppy drive and connected a screen to it. The music, there's no sound card. It's the floppy reader head, just like playing around on the floppy. That's the sound you're hearing, hopefully, right now. I think the demo scene is a bright future because it's even now recognized by UNESCO. That's both in Finland and Germany, and there's other countries coming up soon. Yeah, and then greets and goodbyes. Big documentary, hours long, very interesting about the demo scene. You want to go to a party, hook this up, demoparty.net. They have the list of all the parties going on. There is a surprisingly large amount even today. Revision just happened last weekend. If you know about this huge demo party, they broadcast live. If you ever want to learn about and see what the scene is like, that's the link to hit up. They also have the Meteorics, the Oscars of the demo scene effectively. So if you go look at that list, you'll see what was the best ever stuff made that year. You'll also see the funky things like that floppy demo I just showed you. Demo Zoo is like all the decades of history of the demo scene packed into one. You'll also find all that stuff on archive.org. Big shout out to Jason Scott, who's really behind that preservation effort. A huge thank you to the Open Render community. I love your tool. I hope everybody here will be interested to actually try it out and teased to try it out. There was stuff I was doing with MIDI while preparing for this talk that I did not get to, obviously. I knew this was going to be long. Thank you. This Git will eventually have the slides and the code to this presentation. Thank you again. Thank you for your time, and don't forget to vote, and I hope you have a great Kotlin Conf.